This is a 20 kilowatt, that's right, 20 kilowatt diesel hydronic heater. Now, HLN made this specifically because you asked if one of these heaters could actually heat a building, like an off-grid shack, maybe a pump house, just something like that. And today, we're gonna put this thing through its paces to see if it can actually get the job done. Stick around, that's next. In the quest to find the ultimate diesel hydronic heater for my bus build, I have purchased and tested a lot of diesel heaters, starting in size from this small baby little 5 kilowatt heater here onto this 9 kilowatt. I have the HLN 10 kilowatt, this supposed 12 kilowatt. And early on, I tested this behemoth of a 30 kilowatt. It's the largest diesel heater I've ever tested. Sadly, though, it's not engineered or designed in a way to be very efficient. I'll put a link to the video up here so you can see that. And so it actually outputs less heat than this 10 kilowatt. So it's not really a 30 kilowatt. So I reached out to HLN and I was like, hey, do you have anything on the shelf that might be powerful enough to heat a structure, a cabin or a house or something like that? And he said, yeah, let me see what I can put together. And so he sent me this 20 kilowatt to test. So let me be clear. HLN sent me this heater to test, but this is not a paid review. They don't have say in what I say. They don't have control over what I say. Yes, I am a fan of their quality and of their products because out of all these heaters I've tested, the HLN series is some of the highest quality I've come across. But no, this is my own opinion of this heater, and we're gonna put it through its paces. So let me get this bench cleared off, get it all mounted up, and be right back. I got the big boy mounted on the bench. Let me walk you through the setup here. I have it plumbed into 5 gallons of cool water, and I know what you're thinking because I was thinking the same thing. That's not enough to really test this unit, but since I've tested every other unit with 5 gallons, this is where we're gonna start. I've got a full flask of diesel fuel on the scale. I will be measuring for fuel economy. Because this unit is 24 volt, I ended up purchasing a 24 volt power supply for this, and I will be monitoring power consumption through its entire run, you know. In typical HLN fashion, all of the pumps, the fan and the water pump here are brushless, so they have a very long service life. This unit does have a nice controller. There are no power settings, it's just basically on and off. You can set your time, you can set an alarm clock, you can set a timer for on and off. Now Wi-Fi, I am curious about Wi-Fi. I believe this also has a Wi-Fi app. We're gonna find out. The unit is running, and I have a sneaky suspicion this is gonna be a powerhouse, but I think it's going to be a loud powerhouse. I don't think it's gonna be very quiet at all. If I did mount this on my home or like on a cabin or something, I would probably build an outdoor box for it, a soundproof box. So the back here is 44. It's drawing about 8.4, 8.5 amps. I had to wait for this unit to stop running so I could talk to you because it's extremely loud. Like I was saying, I think this is more of a commercial type unit. You could put this on a bus or something like that, but I think it'd be overkill, and I think it's very loud. And this unit it's not nuanced in the sense that it just has on and off. There's no power settings. Yes, there's a Wi-Fi app. I can access it with my phone. I can see its status, and I can set timers for when it turns on and when it turns off. But it's just on full bore till it reaches 75 degrees C, and then it turns off. And then it's sort of, the water coasts up a little bit. So let's see the results of that test. In this run, we consumed 173.3 grams of diesel fuel, and we heated this 5-gallon bucket of water. And this is not the best test for this unit because it takes a while to get a head of steam up. But we heated this bucket of water from 20.5 degrees C all the way up to 79.6 degrees C. That took 5 minutes and 15 seconds, giving us a efficiency of 63%. That's not bad. And a actual real-world thermal output of 14.9 kilowatts, or 50,700 BTU per hour. It is hauling for 5 gallons. While the 5-gallon test is cool, this is the most powerful unit we've had on the bench, bar none. By the time this unit gets up and rolling, it's already starting to heat the water up in the bucket. So it's not I don't think the 5-gallon bucket's a good test for this. I need to get something a lot bigger with a lot more thermal mass to sort of replicate the real efficiency of this unit trying to heat something large like a cabin. So let me stop this, dump this out, and see if I can get something here to heat up with a large thermal mass. Okay, that took a while. I have destroyed my shop, but this is a 100-gallon stock tank brimmed with water, and I have this heater plumbed to this tank. This will be probably over an hour and a half test to see really what the output is of this. It's too much, but it's what I had, so we're going to do it. As you can see, I have updated my fuel reservoir here to 12 liters. Hopefully this will be enough to get the job done, because this is a lot to ask for this heater to run nonstop for roughly 2 hours. We shall see. All right, I have turned it on. Let's let it get warmed up and see what happens. Right now the pump's drawing about 6.6 amps. The glow plug has not kicked off yet though. Actually, that looks like the glow plug, 6.5. So the glow plug is drawing 6.5 amps. Seems to be max draw as this thing sort of spools up. 18.2. To prevent heat loss during the run, I'm going to be covering the top of the water with a styrofoam. I hope I don't have to stop the test. It's starting to get soft. I think I'm going to wait until it gets down to the 9-liter mark, and then I'll stop the test. That'll give me a nice good baseline. Take measurements and go from there. I guess 66.6 degrees C. That's ominous, but okay. Test is finally over and the results are in. I had to stop the test early. I stopped it when the unit had consumed about 3 liters of diesel. I made sure the meniscus of the diesel was exactly the same on each line. So I stopped it at 3 liters consumed because the tank was about 66.5 degrees Celsius, and being a Rubbermaid stock tank, it's starting to bow. And I was very concerned that if I push it to 75 degrees C, it would lose structural rigidity and would sort of like melt and plop water, 100 gallons of water all over my shop and ruin things. I didn't want that. So here are the results. We heated 100 gallons of water from 18.2 degrees C all the way to 66.6 degrees C in 1 hour, 5 minutes, and 55 seconds. and we consumed 3 liters of diesel fuel to do that. So doing the math, that gives us an actual real-world output of 19.4 kilowatts. That's fantastic. It's rated by HLN for 20. It's giving us 19.4. That's great. The percentage is 71%. In all my testing, any heater that can go above 70% in stock form without messing with the exhaust, trying to scavenge heat, that's class leading. That's excellent. And I'm not 100% sure if putting a heat exchanger on the exhaust would be a good thing. This puts out a lot of heat on the exhaust. It really has a powerful fan. So I'm 100% sure you could scavenge more heat out of this and raise that number to maybe 75%. But at what cost? Would you soot the burn chamber if you did that? I don't know. It may not be worth the squeeze. Let's tear into this thing and see how it's assembled. It's built like a tank, so I'm very curious to see what it looks like inside. And I'm curious to see if we accumulated any soot in that 1 hour run. It didn't smoke at all, so I don't think we did. But let's let this cool down, and then I'll open it up and let's see. Removing this plastic cover here reveals the main wiring harness. And upon realizing I forgot to drain the heat exchanger and dumped half a gallon of water all over my workbench. But I decided to press on and remove the pump anyway, just 4 bolts and 2 hose clamps. And then I borrowed a towel from my wife, don't tell her, and cleaned up the mess. Removing all these plugs allows me to gain access to the pipe clamp style mounts for this. They are bespoke to this unit. There's notches on the bottom where they sort of connect into, but it's a nice solution for this. And now we have revealed the heat exchanger. You know, doing 3 runs on this before I filmed this breakdown, I was curious about soot, one of them being an hour and a half long, and look, we accumulated very little to no soot. This unit burns so clean. And on the heat exchanger itself, yeah, I don't see any appreciable buildup, and it is large enough to consume your hand. This is the largest burn chamber heat exchanger I've come across in an aluminum body unit. The steel body is a little bigger, but they're not made in the same fashion. I am very curious to see how the air is brought into this, because this is lacking the air intake that we're used to, the sort of separate pipe below the bottom. And you can see right there on the bottom right-hand side, that is where the air comes in, and it's drawn in from the back side of the unit on these 6 vents on the back under this dome cover. And I think it draws air past the control module, past the fan motor to cool things down. I also like the fact that the glow plug has its own plug so that I can remove the glow plug without having to worry about wiring. It's just nice that it comes off separately. And there's the cover revealing the main wiring harness, the fan motor, and if you notice, there is the intake port from the backside. I think that's also why that leads credence to this noise. There is no muffler on the intake. It's just a howling, turbine style. And look at those heat sinks. That is the first controller I've seen that has heat sinks. I wonder if this is because it's a more industrial grade or if it's 24 volt. Now remove these 4 bolts off the top and reveal the fan itself. Just look at that machining. That is so pretty. And the fan motor is brushless, so it spins very easily. And there you go. There is the intake port. And it looks like that brass sensor is an exhaust gas temperature probe. This is the first unit I've come across that has exhaust gas temperature sensing. It's very interesting. So I know what I would be thinking at this. Great, Jason, you heated a 100-gallon tub of water. That doesn't mean much to me. I get that. So in order to take the measurements and the data that we collected today and apply it to a more realistic scenario, I had to create a hypothetical house, okay? So I decided to make a 1,500 square foot house, sort of a normal size house, not super big, not super small, kind of a cabin. I decided to put it right in the middle of the spectrum. It's not super efficient, it's not super drafty, it requires 30 BTUs per square feet of heat to heat the space. Okay, and then I decided, where are we going to put this place? Because climate matters. So I decided on Denver, Colorado. Denver has really harsh winters. It also has nice summers, so I thought that would be a really good experiment for this to see how this goes. So taking that 1,500 square foot house, multiplying it times 30 BTUs, it requires 45,000 BTUs per hour of heat to keep it warm during the harshest winter months. Now, from our 100-gallon torture test, we have discovered that this heater can output 66,000 BTUs per hour at 71% efficiency. So that tells me it's more than enough output to heat this home and not run continuously. It will cycle on, cycle off. So that's a good sign. So now, using Denver's actual winter climate data and heating degree days, if you use this heater as your only heat source on this 1,500 square foot house, through the winter will be December to February. So we're just going to hit the harshest month: December, January, February. You're going to burn about 2,100 liters or 550 gallons of diesel. Now, I know that sounds like a lot, but you're thinking this small unit is your only heat for an entire home. I'm not going to stand here and tell you that this is an ideal heating solution for your house. That's not what this is about. This was a thought experiment to see, could you actually do it? Could you heat a home, a structure, with one of these? And the scenario that I see of a person or a situation where you would want to do this is, let's just say you're in you have a remote cabin and you have a truck or some equipment that requires diesel. So you already have a diesel tank on your truck or your vehicle to haul diesel for your equipment. I could see where this would be usable or applicable in that scenario, because if you use propane, you're going to have to haul propane up to your cabin. If you can't get propane or natural gas, then you're going to have to use solar and electric or harvest wood. In my opinion, if I had to use this in my house, I would have a wood stove, a nice either rocket mass type stove or just a really nice wood stove in the center of the house. And then I would use this to run radiant floor heating and supplement the heat in my house. I wouldn't use this as my primary heat, but it would be nice to know that if I had a 100-gallon or a 200-gallon diesel tank up in storage for this unit, I could set this and walk away, and it would maintain the home for me while I'm not there. If I had to go into town for a couple days, I don't want the house to freeze up, this would run and maintain it for me. And then with the Wi-Fi app, I could check my phone and go, oh, how's it doing? I could check to see if it's running, if I had Wi-Fi out there, if I had internet. So it has its place. I don't know how much this heater costs. This is not on HLN's website. I just reached out to Kevin at HLN and just asked them if they even had something like this that might fit the bill for the question that I received of, can you use one of these to heat a structure? And he said, yeah, I've got something on the shelf. Let me put something together and send it to you to test. So they sent this to me to test. They did not pay me to test this. This is not a paid video. This is just more like a fun project to see, can it be done? But if you're actually interested in something like this, the only way to get one is to reach out to Kevin. I got his email down below. Reach out to him, tell him what you're looking to do, and they will put something together for you. And yeah, you'll have a nice, reliable heat source for your cabin, maybe your fishing hut. I don't know. There's a lot of ways you could use this. And I personally, I like underfloor radiant heat, but you could also put radiators in your rooms. Sizing those radiators appropriately would be important. If I was going to do that, I would run the output of this unit into, say, like a water heater tank. That would act as like my heat battery, and then this would heat up that fluid, and then I would have pumps that would run that fluid for the rest of the house. There's many ways to skin the cat. But yeah, this was a pretty cool experiment. Now, I have to get this thing back together and make sure it works. So yeah, if you stayed this long, thanks. I enjoy doing experiments like this. I think There is a way to optimize this and pull more heat out of it. I have a couple of air to water heat exchangers I could try. I'm a little leery to restrict the exhaust. HLN has told me that when you restrict the exhaust on these, you get sooting and fouling because the air fuel ratio is designed and programmed with a free flowing exhaust. So that is something to take into consideration. And I have not tried this with used motor oil or vegetable oil or other types of combustible fluids. You could try it. It would probably work. I don't see why it wouldn't. But yeah, this is the HLN 20 kilowatt diesel hydronic heater. I am Jason Hurst. Thanks for hanging out. I hope you enjoyed it. I'll catch you in the next one. Now I gotta put this thing back together.